All right, let's get right into it. Today, we're going to break down a procedure where every single step is a matter of life and death. This isn't just about getting a job done efficiently. It's about making sure everyone goes home safe.
So, I've got a question for you. Picture a big factory or an industrial plant. What's the most dangerous spot that comes to mind? Maybe the area with all the heavy moving machinery, or the place with all the high voltage warnings? Totally fair guesses, but they're usually not the right answer.
Believe it or not, a lot of the time, the deadliest place is the one that looks completely empty. Yeah, think about it. A big, empty tank, a quiet pipeline, a silo that's been sitting there. We call these confined spaces, and they are packed with dangers you can't even see.
So let's really dig into that idea, the invisible danger, because you absolutely have to understand what makes these places tick, what makes them so uniquely hazardous, before you can even start to think about sending someone inside.
A confined space isn't just any old small room. The official definition has a few key parts. First, it's not a place designed for people to just hang out in. Second, getting in and out is usually pretty tough. And the big one, the most important one, is that the atmosphere inside, it can become hazardous in the blink of an eye.
So what kind of hazards are we really talking about? It's not just the obvious stuff. I mean, sure, you've got leftover sludge, weird chemicals, maybe some hazardous liquids. You've also got dangerous energy sources, like a mechanical arm or an electrical drive that could just kick on out of nowhere. But the number one killer, the thing that causes most of the fatalities in these spaces, is something you can't see, smell, or taste. It's the air itself.
Okay, so if these places are filled with invisible killers, how on earth do you work in one? Well, you absolutely don't wing it. You don't just hope for the best. Nope. You follow a rock-solid, step-by-step procedure to take every single one of those threats off the table before anyone goes in.
And that whole process really comes down to these three key stages. First, isolation. Second, initial cleaning. And third, ventilation. So let's break down what each of these actually looks like in the real world, starting with that first one, isolation.
Isolation is an absolute must. There's no negotiation here. And this is where that famous procedure, lockout or lockout/tagout, comes into play. This is so much more than just flipping a breaker. We're talking about physically locking out pipes, circuits, anything that could feed energy into that space. You put your own padlock on it and you hold the only key. That way, there's zero chance it can be turned on by mistake. It's like creating a perfect safety bubble.
All right, the space is isolated. No rogue energy can get in. Now we get to what is probably the most crucial scientific part of this whole thing. We have to find out what's in the air.
And look at these numbers. This is what's so fascinating. Safety here is a science. These are not suggestions. They are hard and fast rules. Your oxygen level has to be in this very specific window, between 19.5 and 23.5%. Any lower, you can't breathe. Any higher, and things can become flammable like crazy. And those other gases, hydrogen sulfide, carbon monoxide, they need to be at practically zero. No room for error.
And here's the thing. You don't just test the air once and call it a day. You have to keep the ventilation running the whole time, and you are constantly monitoring that air. Why? Because conditions in a confined space can change just like that. That little gas detector becomes your most important tool, your lifeline. Okay, the space is locked out, the air is tested, and good to go. So, now it's time to talk about the people. Because nobody, and I mean nobody, ever goes into a confined space by themselves. This is a team effort where every single person has a vital job to do. It's kind of like a mission to space, right? You've got your authorized entrant. That's the astronaut, the person actually going inside to do the work. Then you have the standby person. This is their lifeline, watching from the outside, in constant communication. You've got the gas tester, the expert who signed off on the atmosphere. And then you have the entry supervisor. That's your mission director. They're in charge of the whole show and have the final say to start, or, more importantly, to abort the mission at any time.
But before that hatch is opened, there is one last final checkpoint, the permit to work, or PTW. And listen, this is not just some bureaucratic paperwork. It's a master checklist. It's the supervisor's signature saying, yes, I have personally verified that every single safety step we just talked about is done, and done right.
So once that permit is signed and posted right there at the entrance, that's it. That's the green light. The mission is officially a go.
But hold on. Just because the main task is finished doesn't mean the job is over. Not by a long shot. The same intense focus you need to get in safely, you also need to close everything out properly. So what does that look like?
Well, first, housekeeping. The team leaves the space just as clean as or cleaner than they found it. Then, they officially close out that permit to work, signing off that the job was completed safely. And only after all that is done do they formally hand the worksite back over to operations. It's a clean handoff so everyone knows the area is safe and ready to go back to normal.
And that really brings us to the main point, doesn't it? Every single one of these steps is a link in a safety chain, from the first lockout to the final signature. There's no such thing as a minor step. If even one link breaks, the whole thing can fall apart.
You know, this whole detailed process, it can seem like a lot, but it's there for a very simple reason, to make sure people don't die. So it really just leaves you with one last question to think about, right? When the stakes are this high, what's the real cost of cutting a corner?